Hey, talking about math and history, and we are going to take a look at properties of special quadrilaterals. So, the last video, we've been taking a look at quadrilaterals, like this stuff right there. And we've been taking a look at the different types of quadrilaterals, like this stuff right there. But what we're going to show is different ways that we can prove that a square is a square, a parallelogram is a parallelogram, and a rectangle is a rectangle. And we're going to show you the properties that you can use as if you were solving a proof. But we got to do this one first, because from the last one, there was a little confusion about trapezoids. So we're going to say always, sometimes, never. Trapezoids have 3 bases. We're going to actually see that there's a never, because this is base number 1, this is base number 2, but the problem is, if you put them on this side, or if you put them on that side, it's not a base, because bases should be parallel to each other, just like squares have bases, rectangles have bases, parallelograms too, and rhombuses. And trapezoids do have 2 bases, but not a third one, because if we do this, they're not parallel. This one is not parallel to that. So no, it will not. So here are the different properties that we can prove as if we were proving something in a proof with shapes. So, going back to what we learned about different shapes, these are, in a nutshell, all the different things that the shape has. Like properties of a parallelogram, opposite sides are parallel, opposite congruent angles are congruent, diagonals bisect each other. So these are the proofs for a parallelogram, or determine a parallelogram. These are the stuff that determine rectangles. These are the stuff that determine kites. These are the stuff that we learned about with rhombuses. And these are the ones for squares. And these properties of isosceles trapezoids too. So, this is a lot to remember, but we can logically think about it if we go back referring to that family tree and also understand what makes those shapes and what do you notice. Like, a square has 4 congruent angles. The diagonals are perpendicular and they have 2 sets of parallel lines. Like that, for example. We can look at this and memorize it, but I think it's a lot easier to logically think if this square can be a rectangle or if this rectangle can be a parallelogram. I hope this video has helped you understand about properties of special quadrilaterals. Thank you for watching Top Fingerlines Math Industry. Like and subscribe.